Welcome to the Using JCache JSR 107 with Coherence screencast. My name is Brian Oliver. I work as an architect within the Oracle Coherence team and as a specification lead for JCache. In this presentation, we're going to provide a brief introduction to using JCache with Oracle Coherence. For the most part, all of this information, together with detailed examples and, in fact, step-by-step tutorials, are available in the Oracle Coherence developer documentation. But for those of you who would like a quick introduction and really don't want to read too much, this presentation is a great start. The presentation has four main sections. Firstly, we're going to talk about the concept of JCache, what it is, where it came from, and where to get it. Next, we're going to talk through the main API. We'll look at some of the methods that are provided and some information on how to use them. After this, we'll look at the steps required to use JCache with Oracle Coherence. Lastly, we'll provide some summary places to go for more information. So let's get started. What is JCache? JCache is the newly standardized caching platform for the Java platform. It's an API. Essentially, JCache introduces a new cache interface that allows developers to access cache-based data structures configured for an application. If you're familiar with the map API or one of the many map implementations, you'll be very comfortable with the JCache API. JCache was developed through the Java community process, like most Java extensions, under the careful guidance of the Java Executive Committee. Interesting to note, while we use the term JCache to discuss the API, you may also hear people talk about JSR 107. This is the Java Specification Request, or JSR, number that JCache was developed under. Should you require detailed information about JCache, it's often also helpful to search for JSR 107. Unlike a lot of JSRs, which typically have a single specification lead, JCache was actually developed under the leadership of three people. In fact, many over several years, each with different caching experience in the industry, including myself. Apart from the leads themselves, there are many large and small companies that provided people and resources, each contributing to the development, review, and testing of the specification. This work has been going on for some time, almost 10 years. Furthermore, numerous individuals, not affiliated with the aforementioned companies, provided valuable contributions to the effort. Ultimately, a lot of industry experts are involved in the design and development of this specification. When we talk about JCache, it's important to understand that in reality it consists of several parts, not all of which are useful to everyone. There's the JCache API, which developers use to interact with cache implementations. There's the JCache reference implementation, or what we call RI, which is a compliant implementation of JCache that developers can use for free. It's open source, like the specification itself, to experiment with JCache. There's the Java Technology Compatibility Kit, or TCK. This is to allow JCache providers to test their implementations to see if they're compliant to the specification. Probably not something that the usual day-to-day developer would use, but anyone that's developing an implementation of JCache, this is really important. And finally, there's a specification doc itself, or often we just call spec, and this defines how JCaches should work and can be used. For the most part, developers using JCache should only be concerned with the API and reading the spec itself, as these define the important characteristics of caches and JCache itself. Typically, only JCache providers play around with the RI and the TCK, though there's nothing stopping developers from using the RI in their applications or experimenting with the TCK. All of these things are open source. In terms of JCache specific resources, which are available for the entire community, the following sites can provide information on JCache. So firstly, there's the JCache official page on the JCP. This provides information about the project itself and all of the official downloads, for example, the API, the RI, the spec, and the TCK. Secondly, we provide the list of contacts for the members of the expert group, including the leads, for example myself. We also have make available the entire source code, so including again the RI, the API, the JCache, and some demos using JSR 107. This is available via GitHub. And lastly, there's a forum site managed by Google Groups where you can contact the expert group and talk to the community and post questions, for example about JCache. If you're using Maven, you can get the JCache API quite simply by using these Maven coordinates. Notice these are just the API itself, not implementations. As you may have gathered, JCache itself is simply a specification for caching in Java, with an API that developers may use. However, these things alone are not enough for an application. You typically require an implementation of the specification for it to work at runtime. In JCP terms, an entity, be it a person or company that produces implementations of specifications, is typically called a provider. Providers and sort of thus their implementations are often categorized in two ways: those that produce compliant implementations and those that don't. A good example of a provider for JCache is Oracle and the implementation in Oracle Coherence. There can be many others, and we assume that there will be many others in the future. Compliant implementations are those that successfully pass the JCache without modification. Any implementations that don't pass the JCache are not compliant and technically cannot use the term JCache, as they do not implement JCache. Ultimately, compliance is very important for developers. It's the only way that developers can be assured that their applications can be portable if they adopt the JCache standard. Application portability is very important to give you choice and flexibility in the implementations you use. Now that you understand the terminology around JCache, let's take a look at the core JCache API. And in fact, let's look at a very brief example of using JCache in an application. Unlike regular data structures, like say maps, lists, sets, for example, developers don't use the new operator to create caches. Instead, developers typically request a cache from a caching provider, or in a container they may be injected into an application. For convenience, JCache provides a simple static method to look up previously configured, what we call named caches, that are currently available through whatever provider is established or configured. If a caching provider isn't configured, then you'll get an exception. So for example, if you just try to run JCache without setting up a provider, then you'll get an exception. But let's assume you have a provider like Oracle Coherence configured, then asking a cache for a specific name cache will produce that cache for you. If that cache is not available, again, you can receive a runtime exception. Once you have a reference to a cache, you can perform operations against it. So for example, like map-based data structures, you can get and put values. So in this example, we're putting in a key and value, the key being the integer 123 and the value being hello world. And then later we can retrieve it from the cache. This is very much like a map. Importantly, however, while caches and their APIs may look like maps, they aren't. Caches may expire or lose or evict data automatically in the background based on some external configuration, or indeed based on system resources. In this way, caches are lossy data structures. Maps, however, don't have this behavior. For example, while an application may put a value in a cache and then attempt to get it again, even immediately, a map would also return the value. In the cache, it may have expired it, and thus, for example, calling cache.get123, if the cache has expired that key, the message may actually be null. This is due to eviction. Again, caches are not maps, and maps are not caches. Essentially, the cache API looks a lot like the map API, but with a few differences. Firstly, it doesn't implement map, though it has a lot of the common methods that you would see in map. Of course, you can get a value for an entry, which will return null if it's not available. You can also get all collections of values for a given set of keys, But additionally, unlike map, you can ask a cache to load a collection of values, say from a configured cache loader. And this is one very important difference from a map. Caches may actually load values. Where the data actually comes from, or the values come from, is up to the cache loader implementation. It could come from a database, it could come from a web service, it could come from any number of places. Likewise, caches may hold on to external resources, for example files, database connections, and hence they are closable, unlike maps. Of course, you can put values into a cache, like a map, but notice it doesn't return the previous value, which is completely unlike the map.put method. To atomically perform a put and return a previous value from a cache, you can use the get and put method. Similarly, you can use get and remove to remove an existing value. For the most part, the entire cache interface is designed in such a way that every operation is atomic. Unlike many caching implementations, JCache is explicitly designed for high performance, low latency scenarios, in which case operations that typically introduce latency into the API are not available. For example, locking an entry is not supported. However, while locking isn't supported, efficient mechanisms to perform atomic operations outside of locks are provided. And we'll cover those shortly. Of course, you can remove and replace entries, but additionally you can remove all and clear all entries. While these two methods seem to have exactly the same semantics, there is a subtle difference. When using remove all, any listener that's registered on a cache will be notified. Whereas when clear is called, no listeners are notified. Probably the most unusual or interesting methods on the cache API are those that deal with entry processes. For the most part, you can think of entry processes as custom functions or closures that are atomically executed against one or more entries in a cache. If you're using or learning Java 8, the ability to execute Lambda functions on an entry, potentially mutating the entry in an atomic manner without requiring locking or synchronization semantics, is what this achieves. That is, anytime you think you might need to use a lock to maintain or have exclusive access to an entry in a cache to do some custom function, then you can use an entry processor. The specification itself provides a lot more detail around the semantics of entry processors. If you're a developer that's used or using Oracle Coherence, you probably recognize the concept of entry processors. Coherence has had them for nearly 10 years, and due to the popularity, we decided to incorporate them into the JCache specification. Unlike maps, caches provide the ability for applications to listen or observe changes in cache data, including insertion, updates, removal, and eviction. This is one reason why we have two methods for removing or clearing entries. The JCache specification also recognizes that many providers and developers may wish to access the underlying implementations of a cache instance, say to have direct access to the implementation of the specification. In which case, developers are provided with the ability to unwrap a JCache cache to access the internal classes. This is fairly rare that a developer would use this. In Coherence terms, this provides the ability for a developer to access an underlying Coherence-specific name cache that a JCache may be using for its implementation. Obviously, when doing so, your application would no longer be portable across providers, and thus it's not a recommended activity. But it is something a developer may wish to use if they want to access specialized functions outside the scope of JCache. While this is the bulk of the JCache API, there's actually a lot more to the JCache specification, including providing the ability to use multiple caches, each with different names and types and configurations. As we've seen in the industry, a lot of caching solutions just provide the notion of a cache. JCache allows us to have many caches of different types, different topologies, and different configurations. The specification also allows the ability to have multiple providers, so you may be using, for example, a reference implementation in part of an application, and then another part of an application you may be using Oracle Coherence, and these can coexist. It also provides the definition for annotations for caching, which is helpful for containers, for example, wanting to use injection into your application. And lastly, it provides the ability to support and monitor caches that are defined by a provider using standard JMX technology. As this is meant to be a brief introduction, it's best to consult the specification documentation on each of these features. Now that we've got some background information on the API, let's look at how to use it with Oracle Coherence. And this is somewhat the easy part. Oracle Coherence 12.1.3 is one of the first commercially available, produced and supported compliant JCache providers. There are several reasons why it's probably one of the first. JCache is essentially a subset of functionality that Coherence offers, and hence JCache built on top of Coherence is a relatively straightforward thing to achieve. Also, the development of JCache occurred alongside development of the Oracle Coherence support, and thus Oracle Coherence implementation of the JCache provider was developed in parallel. Not only does the Oracle Coherence provider support all of the JCache APIs out of the box, including the out-of-box configurations, it also adds the ability to use additional, yet fully compliant topologies for managing cache data. For example, a local cache configuration for a cache instructs it to keep values in the same local JVM as the application using the said cache, whereas a partitioned cache configuration for a cache instructs it to keep the values and the keys in partitions, for example, sharded and distributed across a cluster within Coherence. Each of these configurations are fully compliant, so your application may choose to use one, either, both, or many of these different configurations, allowing developers to tailor how they want to use Coherence. Note, the JCache specification itself doesn't define where cache data is actually stored, and this means providers like Coherence and others can optimize the storage, in fact, even at runtime, including the representation of data and how it is accessed. The Coherence developer documentation provides a good summary of the common features shared by JCache and Coherence, together with some of the extensions provided by Coherence outside the JCache specification. In reality, there are 5 simple steps using JCache with Coherence, and 4 of those are common regardless of which provider you're using. The first step is to really include the appropriate jars on your class path, or have them packaged with your application. To use JCache, you'll always require the cache API jar. This defines the standard API and any helper methods that we ship with JCache. Second, you'll require the Coherence jar. This is the foundation on top of which JCache support for Coherence is provided. And lastly, you'll need the Coherence JCache jar. This is the adapter or the provider for JCache for Coherence. The second step, and this is really the only Coherence specific step, is to enable Coherence to use, or your application to use JCache. And you'll need to do this regardless of how your application is set up. There are really 2 approaches to this. The first is you could use the example JCache cache configuration that's provided out of the box. And you could, if you're only interested in using JCache itself and none of the Coherence features or none of Coherence native caches, then you can simply specify a system parameter to tell Coherence where to pick up the cache configuration. In this case, -d Tengasol Coherence cache config equals Coherence JCache cache config.xml. Assuming you've placed the cache API, Coherence, and Coherence provider in the class path, this will automatically be found. The second approach, which really applies to customers who are already using Coherence to enable JCache support, and is quite easy. Again, you have to have the right artifacts in your class path, but all you need to do is add this XML namespace to your cache configuration, and that will automatically configure the required JCache cache infrastructure. Once you've set these things up, step 3 is really to acquire a cache manager from the caching provider. The idea is that the caching provider manages a set of cache managers, and the cache managers themselves can manage one or more caches. In a typical application, there will be one, what we call a default caching provider, and you'll probably just use one default cache manager. And this is how you obtain them. Step 4 is really configuring JCache caches. If you're used to Coherence, most of the times configuration is done through the cache config file. In JCache, they can actually be created programmatically. So in this case, we're using the standard JCache mutable configuration that comes out of the box. In this case, we're going to configure a cache which has string keys and integer values. And we're saying that the configuration of this cache will be stored by value. You could obviously say store by value is false, meaning store by reference, and we can specify the types. So once we've set up our configuration, the last step is to ask the cache manager to create the cache for us. And notice we have to specify the name. So we say cache manager create cache name, in this case ages, and what configuration. And that will return a cache that we can then use. If a cache already exists with that name, you'll get an exception. If the manager can't produce a cache using that configuration, you can also receive an exception. Now that you've created a cache, you can use either the cache manager or the caching helper methods to request a cache. Or we could use, for example, the cache that was returned from create cache. So in this case, we're requesting from the cache manager the ages cache that was defined from the key class string and the value class integer. Should these types be incorrect, you'll receive an exception. Once we have our cache, then we can interact with it. We can put some values into it. And of course, then we can receive values from it as previously demonstrated. There's really a lot of information available concerning JCache. One of the best places to start learning about JCache is actually the specification document. It's freely available to download from the JSR 107 site and contains numerous examples together with detailed explanations of the API. Alternatively, you could peruse the JCache API Java doc, which is also quite detailed. When you're done learning about JCache, you'll then probably want to learn how to use it with Coherence. And the best place to start is working through the information contained with the Developing Applications with Oracle Coherence book, which is freely available to download from the above reference. In this talk, we introduce the concept JCache, the new caching standard and API for the Java platform, together with the first steps to use JCache with Oracle Coherence. Thank you for your time. I hope this brief introduction will inspire you to look further at JCache and standardize your application caching requirements, together with Oracle Coherence as your preferred JCache caching provider.